So these are going to be our final notes on work and power and energy. Just take your time doing these, and let's kind of get started with this. We're going to move this up a little bit for a minute. Let me get this started. Almost forgot. But okay, so if you remember, we've been looking at energy, and energy and work are closely related. And work, let's just start putting this in here. Work is force times distance. Okay, so if you apply a force to something and move it a certain distance, you've done work. The unit is joules. And then work is closely related to energy, especially kinetic energy. And we have two types of energy. We have kinetic energy, Ke, and we have potential energy, Pe, and we have gravitational potential energy, this one right here. We have elastic potential energy, EPE, and gravitational is based on height or position, kinetic energy based on motion, and all of these have to do with energy and work. They're all interrelated. So this is position, and this is material. So like a bungee or any type of substance that has stretch to it or will bounce back, that's elastic potential energy that's contained within that substance. Even a spring, you compress it, it bounces back. So these are all related. Our last term here is work, so I'm going to erase these. Or I'm sorry, not work, but power. And power is a rate at which you do work. And a rate usually has something to do with time. It's how long a certain task takes to get done. Okay, so time is a big one. Like a good example of that is miles per hour. That's a rate. MPH, miles per hour. And like a car goes 55 miles per hour. So you went 55 miles, it took you 1 hour. So power, though, has to do with how much work you do over a given time frame. The equation for work is P equals W divided by T, and that's really work divided by time, and that's where the rate comes in. Okay, and then also you can take this work and just make it into force times time. So this can become something else. So if it gives you the force and the distance instead of giving you the work, you can just plug that in. So then we're going to do a practice here in a minute, but the unit is the watt. James Watt is a person that did a lot of work with heat and energy, so they honored him by naming this unit, the unit for power, after him at the watt, the W. And 1 watt is equal to 1 joule, which is the energy, in 1 second. So 1 watt of power is when you expend 1 joule for 1 second. The one thing we're probably used to seeing the watt with is something that electric companies do, and they charge for their electric power by kilowatt hours, and a kilowatt is 1,000 watts. So if you use 1,000 watt hours, they charge you a certain rate. And power is a pretty easy thing. So let's do an example problem here, and then we'll be done with our notes. So we have this problem. It says how much power is needed to move a 3 kilogram rock 4 meters if it takes 5 seconds to move the rock. So if we write down what we know, we want to know power. We know the mass is 3 kilograms. And then we know the time is 5 seconds. We're just going to put a 5 for that. And then we know the distance is equal to 4 meters. Okay, now if you remember, our equation is power equals work divided by time. But we don't have work. We do have the distance, but we don't have, because this could be force times distance, we don't have the force. So instead, what we could do is we can figure out, well, what is the force it's going to take to move a 3-kilogram rock? Well, the only force acting on it is the force of gravity. That's the force we'd have to overcome. The force pulling it down towards the earth. And if you remember, the force of gravity is mass times acceleration, which is 9.81. So then if we just take that, the mass, which is 3, and we multiply it by 9.81, we'll get a force that is acting on it. So let's do that. So we do 3 times 9.81, and we get 29.43. So we'll say, we'll just move this over, we'll say 29.4. That's the force. And then we just take that by the distance, so 29.4 times 4. Then if we divide that by the time, which is 5, we'll get the power it will take. Not that much, really. So if we do the math, 29.43, or math, not massed, math, 29.4, we multiply that by 4. It's going to give us 117.72, and then we divide by 5, and we get 23.5. So the P is 23.5, and the unit is watts. And that's kind of how you solve these. That's your answer, 23.5 watts. So let me know if you have any other questions on this. There's lots of different ways you can get the work, though, or the force. Sometimes it'll give you the force as in newtons. Sometimes you have to figure out the force by overcoming friction. That's kind of how you do them. Let me know if you have any questions. You should be able to do these problems when you come into class. That's my expectation. And see you soon.